All right, so this is the explanation video for this hybridization problem, and this is a pretty common type of problem to walk through. So in the first part of this, we're going to draw a Lewis dot structure for formaldehyde. It's a pretty easy Lewis dot structure to draw. If I see this Ch2O, I know that we're going to have both of the hydrogens bonded to the central carbon, and then I'm going to have a double bond to oxygen. And then it says repeat the steps from before, so this is talking about what we did on the previous side of this handout. But the first thing that I would do is I would figure out what the hybridization is for each of my carbon and hydrogen. So this carbon has Sp2 hybridization. I've got 3 groups arranged around it. I see that I've got a double bond, and I know that the angles here should be about 120 degrees, so that's going to be Sp2 hybridization. For this oxygen, I've got 2 lone pairs and then a bond to carbon. So again, I would count that as 3 groups, so that's going to be my Sp2 hybridization as well. So that's step 1, draw the Lewis dot structure and figure out what the hybridization is. And then it says for me to describe the bonding around the carbon atom and the oxygen atom using our hybrid orbital picture and our hybridization of our atomic orbitals. So for carbon, the first thing that I would do is I would start with the atomic orbitals. So we're going to say a 1s, a 2s, and our 2p's, our 3 2p's, and then I'll fill in the electrons for just a neutral carbon atom. So this carbon atom, before it started bonding with oxygen and hydrogen, this would be the electron configuration for that carbon atom. I'm going to do a hybridization, so let me grab a different colored pen. Since it's Sp2 hybridization, what that's telling me is that I'm going to take my s orbital and then 2 of the p orbitals. So Sp2, the significance of the 2 is that I'm talking about 2 of the p orbitals. So I'm going to take those orbitals and I'm going to hybridize them. I'm going to leave this 1s here. This is a core electron, so it's not going to be participating in bonding, but it's nice to just show it just so that we don't forget about those electrons. So when I hybridize these, I'm going to do an Sp2 hybridization. I'm putting 3 orbitals in, and I'm going to get 3 orbitals out. So I'm going to draw those in as my Sp2 orbitals, and they're going to be somewhere in between energies between the s and the p orbitals. And I've got 1 leftover 2p, so I'll put that 1 leftover 2p right over here, just bring it over. Now I'm going to start filling in the electrons, and regardless of where the electrons are on my atomic orbital picture, that doesn't really matter. I'm just going to say I've got 4 more electrons to put in, and I'm going to start putting them in over here. When we're filling in electrons for our hybrid orbital picture, we're actually going to fill in left to right, top, bottom to top, but we're not going to start filling our Sp2 before we put an electron into that 2p. So it's a little bit different than how we filled electrons before, but 1, 2, 3, 4, and then if I had 1 more electron, then I would start pairing down here. The reason for that is that I'm going to be filling these with shared electrons from my other bonds. So the way that I would draw this is I would put in those 2 electrons, and each one of these really represents a carbon-hydrogen sigma bond. So what I'm showing here is that these are my Sp2 orbitals. This would be Sp2 orbital, Sp2 orbital, Sp2 orbital, 120 degrees apart from each other. And so this carbon-hydrogen bond, this bond right here, we can represent that by this orbital with 2 electrons in it. That's where those electrons come. And then the green electrons, those are being shared from hydrogen. Hydrogen is going to be bringing an electron essentially. So we're going to be sharing those 2 electrons. So this right here would be maybe this bond, and then this right here, that would be this bond over here. Now this other Sp2 orbital, that's going to be my Cc sigma bond. So I've got a sigma bond between the carbon, or excuse me, CO sigma bond. So I've got a sigma bond between this carbon and oxygen. That's the first bond of the double bond. And this other electron here, that's going to be coming from oxygen. Oxygen is going to be sharing that electron with the carbon, so that fills up my Sp2 orbital system. For the 2p, I'm also going to have another electron from oxygen, and that's going to be my CO pi bond. So that's going to be from the leftover p orbitals sticking up and down, overlapping. That's going to be the CO pi bond. So I've got 2 bonds, 4 electrons for that CO double bond. And I can see where those all come from. We'll do the same thing for oxygen, and when we do the same thing for oxygen, then we can combine sort of both of our pictures and see where all the electrons, all the valence electrons, are from my actual Lewis dot structure. The whole point of this is to take our orbital pictures and then look at them in terms of our actual Lewis dot structures. So for oxygen, we'll draw out our atomic orbitals first, 1s, 2p. Now oxygen has 8 total electrons, 6 valence electrons. So this would be my atomic orbital picture. These are my 6 valence electrons. I'm showing my core electrons here again. That's not totally necessary, but I think it's nice to do. We're going to do Sp2 hybridization again. So I'm going to take the s orbital, 2 of the p orbitals, do my hybridization. So it's going to look just the same as up here. We'll leave that 1s core electrons in there. 1, 2, 3 sp2 orbitals with 1 leftover 2p orbital. Start filling my electrons in. Obviously my core electrons are going to be full. 1, 2, 3, 4, 5, 6. So that's the way that I would fill those 6 valence electrons from my atomic orbitals into my hybrid orbitals. I've got 6 total electrons here. Again, I don't care that 5 of them are within this green box. We're going to do sort of 2 separate processes, hybridization and then filling the electrons however many we have. 1, 2, 3, 4, 5, 6. What these represent then are the lone pairs of electrons, right? So that oxygen up here, it's got these 2 lone pairs of electrons, and that is represented by our 2 lone pairs of electrons that are filled by those oxygen electrons. So these are my lone pairs. Then I'm going to have an electron being shared from the carbon, so that would be sort of right here. So this is going to be my oxygen carbon sigma bond, and then I'll have the same thing as as I have on my carbon, my oxygen carbon pi bond. So what I have here and here, they're really sort of showing the same thing, right? That's going to be the sharing of those electrons. And then what I have here and here, that's showing the same thing. That's where, you know, like this electron from oxygen is actually this electron right here that's in green, and this electron from carbon is actually this electron here. So these are really sort of the same thing, right? And these are also really sort of the same thing. These are my carbon-hydrogen bonds. These are my lone pairs of electrons on my oxygen. So this diagram should translate essentially into our Lewis dot structure, and we should be able to see or sort of point out a sign where all of these electrons are in my Lewis dot structure. That's the whole point. All right, hopefully that helps. Let me know if you have any other questions.